Hello, good day viewers. In this tutorial, I'm going to show you how to graph a piecewise function. The graph of piecewise function is a graph of multiple functions constructed on the same graph on different intervals for which every terminal point can satisfy at most one function. I'm going to explain this at the end of this tutorial. So you can see we have four functions that we are going to construct on the same graph. But look at the intervals here. We have to abide by the intervals, right? So let's get started. So the first function we are going to construct is f of x equal to 0. This means y equal to 0, right? Graph of y equal to 0 is a horizontal graph on x-axis, but we have a condition. This graph is at x less than 0. So it will start from the origin backward towards negative infinity, right? So let's construct it. But looking at the interval, it implies that 0 is not part of the domain. So we are going to make an open cycle here. So this is the graph of f of x equal to 0. We are done with this one. Now the next function is f of x equal to x, which implies y equal to x, right? If y is equal to x, it implies that every point you plug for x will be the same for y. So when x is 1, y will be 1. When x is 2, y will be 2. When x is 3, y will be 3, in that order. But look at the condition here. It stated that from 0 down to 1, including 0, excluding 1. So 1 is not going to be a solution. So we are going to start from 0 and stop at 1. So let's plug the point. We have 0, 0 with a closed cycle here. Since 0 is a solution, then we have 1, 1. We're going to stop here. Remember, it is a straight line graph. So we're going to connect this point to this point together. But since 1 is not a solution, we are going to make an open cycle at the end. Something like this. So this is a graph of f of x equal to x. Then moving on to the third one, which is quadratic. It is going to be constructed between 1 down to 3, excluding 3, but including 1. So I need only 3 points. So what is the value of y when x is 1? You can see when x is 1, we have negative 1, because 1 squared is 1 times negative is negative 1. 1 times 4 is 4, so we have plus 4 here. Then minus 2. Negative 1 plus 4 is positive 3. 3 minus 2 is equal to 1. So when x is 1, y is also equal to 1. Let me bring the points here. 1, 1. So what happened when x is equal to 2? We have 2 squared here is 4 times negative. We have negative 4. 2 times 4 is 8 plus 8 here. Then minus 2. Negative 4 plus 8 is positive 4, and 4 minus 2 is equal to 2. Likewise, when x is 2, y is also 2. And the last point, when x is 3, we have 3 squared is 9, negative 9, and 3 times 4 is 12, so we have 12 here, then minus 2. So you can see 12 minus 2 is 10, and that 10 minus 9 is 1, so the whole of this is 1, which implies that when x is 3, y is 1. So we have 3, 1. So let me plot these 3 points. Let's start with 1, 1, which is inside this cycle. But remember here, 1 is a solution because x is greater or equal to 1. So we have a closed cycle inside this cycle. Then 2, 2. Where can we find 2, 2? You can clearly see 2, 2 here. This is a point. Then we have 3, 1. This is 3, and we have 1 here. So we add a point, 1, 1 right here. So now let us connect this together. It is going to be a parabola. And you can see 3 is not a solution. So we are going to make an open cycle here. All right, now we are done with this curve. Let me give it a name. This is f of x equal to negative x squared plus 4x minus 2. And if you like, you can include the intervals. Then the last function we are going to construct here is a graph of y equal to 4 minus x, but we are only interested in x greater or equal to 3. So we are going to test for x equal to 3, x equal to 4, 5, in that order. So if y is equal to 4 minus x, this is a linear graph. So when x is 3, we have 4 minus 3 equal to 1. So you have 3, 1. So let me choose another point. When x is 4, we have 4. Then 4 minus 4 is 0. So we need only these 2 points. I think they are enough for us. 3, 1. Where is 3, 1? 3, 1 is exactly into this open cycle. But you can see 3 is a solution here. So we are going to make a closed cycle in this open cycle. Then we need a point where x is 4 and y is 0, which is exactly on x-axis here. So we are going to connect these 2 points together. So this is a graph of f of x equal to 4 minus x. All right, this is exactly how to construct a piecewise function. But remember, I told you there is no any terminal point that can satisfy more than one function. Look at the terminal points here. We have some of them here. We have 3 terminal points. Let's check them one after the other. You can see the first one here, which is 0. 0 only satisfies the second function, because the first function is less than 0. Therefore, 0 will not satisfy it. But the second function says x is greater and also equal to 0. So it only satisfies the second function. Then let us check another one. You see we have another point here when x is equal to 1. X equal to 1 only satisfies the third function, because in the third function you can see x is greater than 1, also equal to 1. But here it is less than 1. Then the last point here, when x is 3, it only satisfies the last function. But second to the last function says x is less than 3. So this is what I mean by every terminal point can only satisfy at most one function. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos.